This is Dr. Karthika from the Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about radiation and radioactive decay in medical physics. And thus we are going to discuss about ionizing radiation and its types here. First of all, what do you mean by ionizing radiation? We know that ionization, it is defined as the radiation capable for producing ions when interacting with the matter. In other words, the enough energy to remove an electron from an atom, it is called ionization. The sources, it may include X-rays, radioactive material that produces alpha, beta and gamma radiation, cosmic rays from the sun and space. These are all considered as the sources of ionization. Okay. While talking about this ionizing radiation, we have to consider alpha, beta and gamma rays. While speaking about the energy of the alpha, beta and gamma rays, the energy level of alpha is low. The beta is medium. For gamma rays, the energy level is high when compared to alpha and beta. Okay, then what do you mean by this radioactive material? Here, the radioactive material, it can be either natural or created in nuclear reactor or any accelerator. Here, this radioactive material, it is more or less, it is unstable and it emits energy in order to return to a more stable state. It emits particles or gamma rays. Here, we have to consider the half-life time for radioactive material to decay by 1/2 by emitting radiation. Okay, in this, the output is either alpha, beta or gamma. Okay, first we are going to see about alpha particles. Here the alpha particles, it has 2 neutrons and 2 protons. Here the charge of +2, it emits, and the alpha particles emitted from nucleus of radioactive atoms. Here the energy transfer, the transfer energy, it is for very short distances. For example, 10 centimeter in air. It is shielded by paper or layer of skin too. The primary hazard from internal exposure at the alpha emitters, it can accumulate in tissue, bone, kidney, liver, lung, spleen, causing local damage. Okay, while moving into beta particles. Beta particles are small electrically charged particles similar to electrons, the charge of -1. It was ejected from nuclei of radioactive atoms emitted from various kinetic energies. It was shielded by wood body penetration 0.0 to 1.3 centimeter depending on the energy we have, and it can cause skin burns or be an internal hazard of ingester. Okay, while moving into gamma rays, the electromagnetic photons are radiation. It was identical to X-rays except for source. It was emitted from nucleus of radioactive atoms, spontaneous emission we call, and the gamma rays are emitted with kinetic energy related to radioactive source, and this gamma rays are highly penetrating. Extensive shielding is required for gamma rays and it can cause serious external radiation hazard. Okay, then what about X-rays? X-rays are overlap with gamma rays. Here the electromagnetic photons are radiation produced from orbiting electrons or free electrons, usually machine produced. It produced when electrons strike a target material inside the X-ray tube. X-rays emitted with various energies and wavelength. X-rays are highly penetrating. Extensive shielding is required as like gamma rays, and it can cause external radiation hazard, and these X-rays are discovered in 1895. Okay, then we talk about ionizing radiation health effects. We evolve with a certain level of naturally occurring ionizing radiation from cosmic radiation, radioactive materials in the earth. We have mechanisms to repair the damage also. Okay, here we are going to discuss about the radiation units. Okay, and thus we have exposure, absorbed dose and equivalent dose. Exposure, it is related to energy. Absorbed dose, it is amount of the energy absorbed. And equivalent dose, it makes different sources of radiation equivalent. Okay, and we have the standards for ionizing radiation. Here we concentrate the two standards. One is NCRP and another one is ICRP. NCRP is US National Council on Radiation Protection. ICRP is International Council on Radiation Protection. Here the occupational exposure guidelines, it involves 100 MSV over 5 years, average 20 MSV per year with maximum of 50 MSV in any 1 year. The general public, the background about 3 MSV per year, and the guideline is 1 MSV per year is recommended for the people and general public also. Thank you.